Linear and quadratic inequalities. You need to be able to solve linear inequalities, sometimes more than one together. An inequality will give a range of possible answers rather than a specific values. Equations give specific values, inequalities give a range of answers. But we solve them pretty much in the same way that we solve equations. The only difference, and this is the key difference, is when you multiply or divide by a negative, you must reverse the sign in an inequality. So bigger than becomes less than, and less than becomes bigger than. So find the set of values for which 2x minus 5 is less than 7. Solve it just like you would an equation. So add 5 on, 2x is less than 12, divide by 2, x is less than 6. So treat it as you would an equation, but just watch out for the times when you multiply or divide by a negative number. 5x plus 9 is bigger than or equal to x plus 20. So take the x away. 4x plus 9 is bigger than 20. Subtract the 9. 4x is bigger than 11. And then divide by 4. X is bigger than or equal to 2.75. 12 minus 3x is less than 27. Take 12 away. Minus 3x is less than 15. Divide by 3. Minus x is less than 5. So then, when we multiply by minus 1, we have to remember to turn the inequality sign into the other direction. So x is bigger than minus 5. You obviously could have gone there straight from the second line and divided by minus 3 and turned the sign around and got the answer. The steps there are to make it clear what is happening. 3x minus 5 is bigger than 5 minus 2x minus 8. Now, let's get rid of those brackets first, being careful with negative signs. 3x minus 15 is bigger than 5 minus 2x plus 16. Let's add the 2x and do a bit of grouping. 5x minus 15 is bigger than 21. Okay, add 15 on, divide by 5. As straightforward as that. 3x minus 5 is less than x plus 8. And 5x is bigger than x minus 8. In this case, we're finding numbers that satisfy both inequalities. So if we solve the first equation, subtract x, add 5, divide by 2, x is less than 6.5. If we solve the second equation, subtract x, divide by 4, x is bigger than minus 2. So what are the numbers that satisfy both inequalities? If we draw a number line out, we can see in one we've got x is less than 6.5. In the other we've got x is bigger than minus 2. So the only ones that satisfy both are where we've got the two lines between minus 2 and 6.5. So minus 2 is less than x is less than 6.5 satisfies both inequalities. So when we're faced with questions like this, make sure that we draw out a number line, draw the inequalities or the range of the inequalities on the number line, and then see where they overlap to find the ones that satisfy both at the same time. If there's just one region, it's one single inequality. If they overlap in a couple of different places, then we'll have two inequalities. X minus 5 is bigger than 1 minus x, and 15 minus 3x is bigger than 5 plus 2x. So solve the first one. x is bigger than 3. Solve the second one. 2 is bigger than x. So x is bigger than 3, we can show us that. 2 is bigger than x is less than 2, which is all of that way. Where do they overlap? They don't. So in this case, there are no answers that work for both. Sometimes when we have to find solutions that satisfy one equation and another equation, there may be no answers. If so, make sure the working is clear and make sure you say there are no answers that work for both. 4x plus 7 is bigger than 3 and 17 is less than 11 plus 2x. Solve the first inequality. Solve the second inequality. Draw the number line. X is bigger than minus 1 is all of that. 3 is less than x, or alternatively x is bigger than 3 is all of that. Where do they overlap? Where they overlap, bigger than 3, all of it. Everything that's bigger than 3 is where they overlap. It's just that little bit between minus 1 and 3 where there's no overlap. So that's not the solution to both, but everywhere else is the solution to both. X is bigger than 3. Quadratic inequalities. In order to solve these, first we solve the quadratic equation. Then we sketch a graph of the equation. We looked at that back in the quadratic video. And then we decide which is the bit. We have to go through this process. We have to do the sketch. So find a set of values for which x squared minus 4x minus 5 is less than 0. So, firstly, solve it. Factorise, get the solutions minus 1 and 5. It's x squared, so it's a U-shaped graph. It goes through minus 1 and 5. They're the key things you have to know there. So U-shaped, between minus 1 and 5, we draw a sketch. You must draw the sketch. Then you can say to yourself, fine, where's that less than 0? Well, it's less than 0 in the bit between minus 1 and 5. That's one single continuous region, so there's one inequality, which is minus 1 is less than x is less than 5. X squared minus 4x minus 5 is bigger than 0. So again, factorise it, solve it, get the solutions, draw the sketch. This time we're trying to find out where is it bigger than 0. So that's in these two regions there. When you have two separate regions, you have two separate inequalities as the answer. So x is less than minus 1 satisfies the quadratic inequality, and x is bigger than 5 satisfies it. So you have both. 3 minus 5x minus 2x squared is less than 0. So again, solve it. If we firstly times by minus 1 to make it a bit nicer, and then it will factorise. Then we can see the solutions are 0.5 and minus 3. It's minus 2x squared, so when we sketch it, that's going to mean it's an n-shaped quadratic. It's an n-shaped quadratic that goes between minus 3 and 0.5 for the roots. We want to find the bit where it's less than 0. So less than 0 is below the x-axis. So it's those two separate bits. So it's two separate inequalities. X is less than minus 3. X is bigger than 0.5. I will one time more though say you need to sketch the graph when solving quadratic inequalities.